we have done so many things for functions and to solve the equations. And now we're going to try something new, and that is the polynomial and rational inequalities. Polynomial and rational inequalities. That means not equal to, right? Equation, which means equal to, and inequality is not equal to. So let's deal with the polynomial first. Polynomial equation. Inequality, sorry. Inequality. Okay, so you have f of x, a function, and I ask you to solve for not of f of x equals 0. I want to solve it for f of x greater than 0, greater than or equal to 0, less than 0, less than or equal to 0. Something looks like this. That's the inequalities, right? So let's see, how should we do that? Tell you how to do it. The first step is always to solve f of x equals 0 to get the solution, and then we call this a solution boundary line, and then we do next. I'm going to tell you how to do that. All right, now let's look at the first example. I ask you to solve this. Solve 2x squared plus x greater than or equal to 15. How do you solve this? Now, this one is equivalent to, if you subtract 15 on both sides. For inequalities, then you can subtract or add the same amount for from both sides and without changing the direction of this sign. So that becomes 2x squared plus x minus 15 greater than or equal to 0. Okay, you want to make the right side to be 0. So we're going to solve this. 2x squared plus x minus 15 equals 0. This is a quadratic equation. How do you solve that? Two-way. One is A, B, C, and then you're going to use the quadratic formula. The second one you can factor. You get a 2x minus 5 times x plus 3 equals 0. If you're not familiar with factoring, then you can, of course, you can use this. X equals 2a negative b plus minus b squared minus 4a. So I repeat this so many times, I hope that you can remember. But anyway, so we use a factor and we got that, and then we solve this. We get a 2x minus 5 equals 0, or x plus 3 equals 0. So x equals plus 5 divided by 2. So I get a 5 over 2, or you can say 2.5. That's okay. Okay, and this one is x equals negative 3. So do you see that? You get these two solutions. All right. Now, once you have these two solutions, we call them boundary points, or boundary points. Boundary points is 2.5. Here's 1, 2, 3. So this is 1. And the other one is negative 3. So 1, 2, 3. And here's a y, here's a x, here's a 0, and a 1, and a 1. Okay, so we found these two boundary points. Next thing, there are several different ways to do it. One is you graph it. Can you graph f of x equals 2x squared plus x minus 15? And this a is positive, so it's going to be like open up. You don't really need to get a very accurate graph, but you can just show me the pattern. So this is negative 3, and this is 2.5. If you have this pattern, then I am asking you is when this guy is greater than or equal to 0. Greater than or equal to 0 means above this x-axis. So where they are from here to the right and from here to the left. Can you see that? Therefore, your solution is this. Write in the interval notation. That will be from negative infinity to, can that be negative 3? It depends on your inequality has the equal sign or not. This one has the equal sign, so that could be 3, and that could be 2.5. So that will be from negative infinity to negative 3, or from 2.5 to positive infinity. Okay, this is pretty easy when you have this quadratic, because quadratic you already learned very well how to do it. Okay, so what happens if you have a polynomial function that is not quadratic? If it's f of x is not quadratic, but you do have like 1, 2, 3, you have 3 critical value. You can either use the graphic calculator to get the graph and to determine where you're going to have the graph above 0, greater than or equal to 0, or less than 0. Then you can determine which interval is your solution for the inequality. So that is the way. And of course, whether you're going to choose the parenthesis or bracket depends on in your inequality, can that have equal or not equal to. So you got to think a little bit. Okay, so this is the one way to find the solution for the polynomial inequality. This is fairly simple. Okay, and the second one is, how do you solve a rational inequality? For example, I give you this one, x plus 1 over x plus 2 greater than or equal to 0. If I give you this, can you solve it? This is a rational, right? Because there's a polynomial over polynomial. So what I ask you to do, the same thing, you have to find the boundary point or the critical point, whatever you call that, is the most important one. That is the x value make both the numerator, either numerator or denominator to be 0. So if you make the numerator to be 0, you get x equals -1, right? If you have x plus 2, the denominator to be 0, then your x got to be -2. And of course, we know that x cannot be -2 at the end. Keep this in mind, because that's your domain. Okay, the x cannot be -2. But anyway, you have a -1 and -2. Okay, so what are you going to do next? You are going to do this. 0, -1, -2. All right, so think about the number line. You have a -1, -2. These 2 points break your interval, break your number line into 3 intervals. So what I would ask you to do is pick a test number, a test number, a test number in each interval, and then bring them into your original inequality to see whether it holds. If it holds, then that interval, the whole interval, will be good. For example, I choose 0. Okay, I pick 0 in this part. Okay, when it's 0, 0 plus 1 over 0 plus 2. Do I get a 1 over 2? So that's a positive. That's a good thing, because it's a greater than or equal to 0. So that means the number from -1 and above is good. Okay, not -2. Let me just cross this out at the first. But then, because it's equal, so that means a solid point to the right, and the whole thing here is good. Okay, and from -1 to -2, I can put I put a -1.5. How about that as my test value? And then I put in -1.5 into here. If -1.5 plus 1, which is going to be -0.5 on top, and the denominator -1.5 plus 2, I get a positive 0.5. What do I have? I have a -1. And that's not greater than or equal to 0. That means anything between these two values or in this interval is no good. So I just simply cross that out. Okay, so that's, as long as there's one test value make this inequalities correct, then the whole interval will be good. Now try one more. Here's a -2. What are you going to choose? You might want to choose -3. So let's try -3. If you put a -3 here on top, you get a -3 plus 1, which is -2 on top, and the denominator -3 plus 2, you get a -1. So what do you have? The left side, you have a 2. Is that a greater than or equal to 0? Yes. So which means from -2 to the left is right. All right, now, so we have this interval correct and we have this interval correct. So my solution is very tricky here. My solution is anything from a negative infinity to negative 2, but it cannot include negative 2. See, there's so many things you have to consider, okay? I'm so sorry for that. So x cannot be negative 2, so that will be negative infinity to negative 2, but parentheses, or anything from negative 1 to the right. And here is equal, right? Here's equal. So negative 1 is okay. And so that would be close or bracket from negative 1 to infinity. This is pretty hard. Okay, this is pretty hard because there's so many things that you have to consider. Okay, isn't it interesting? I don't know. I think it's interesting. All right. So I think that's one. All right. Now one more thing. The hardest part. Hardest part is this. Hardest part is solve x plus 1 over x plus 2 greater than or equal to 2. Now this is a little different than the one we had earlier. The previous one is greater than or equal to 0, but now it's 2. Okay, if this is the situation, you have to subtract 2 from both sides because you really want to make your right side to be 0. So x plus 1 over x plus 2 minus 2 greater than or equal to 0. This is equivalent to that. And then here we have to make that as a rational function because we cannot do this right now. Then we're going to use the least common denominator. The first part is x plus 1 over x plus 2. And this one we have the least common denominator x plus 2. And here will be twice of x plus 2 greater than or equal to 0. You see what I'm doing here? Okay, this 2 is actually 2 over 1, and the least common denominator is x plus 2, so I multiply by x plus 2 for both numerator and denominator. All right, now I can continue. The denominator is x plus 2, and the top I have x plus 1, and then I go minus 2x, I go minus 4, okay, greater than or equal to 0. Not done yet. The numerator is a negative x minus 3. The denominator is x plus 2 greater than or equal to 0. Finally, I got something looks like the one I know what to do. I continue. Gosh, I have so many things to worry about, huh? All right, I continue. I try to solve for the numerator equals 0 and the denominator equals 0. So in this case, x will be negative 3. Okay, so because I plus 3 on both sides and then I change the sign. And this one, x equals negative 2. Wow, I got a negative 2 and a negative 3. Those are my most important numbers. So negative 3 and a negative 2. And remember, I have this x plus 2 in the denominator. So let me just get rid of that right away. X cannot be negative 2. All right, then it's complicated, isn't it? Then I will pick test value, bring that into this inequality and to see which one works. So what is the test value like? I would put 0 because here's negative 2, so I just put 0. And then if 0 as x, that will be negative 0, and the negative 3, and the 0 plus 2, which is 2, so it's a negative 3 over 2. It's not greater than or equal to 0, so this interval is no good. And what about a negative 2 and negative 3? Between that, I will pick negative 2.5. Let's do that. If I put a negative 2.5, negative 2.5 is a positive 2.5 minus 3, I get a negative 0.5 in the top, on the top. And the bottom, negative 2.5 plus 2, I get a negative 0.5. So the answer is 1. Is that greater than or equal to 0? Yes. Okay. And then the last, negative 4. I put negative 4. I choose negative 4. Of course, if you like, you can choose -5 or -6, negative whatever, okay? So if I put a -4 here, that would be -4, so it would be 4 minus 3, the top is 1, and then the denominator -4 plus 2 is -2. So that's -1/2. Is that greater than or equal to 0? It's not. So basically, I only have this interval correct. And then I got to be very, very careful when I write the answer. Should I write bracket or parentheses? Of course, this is going to be parentheses because I know it cannot be -2. But what about -3? I have to look at this sign. Here has an equal, so that means it could be the other one. So the solution is this. It's from -3 to -2. That's my solution. I'm going several steps. See, I ask you to solve for this inequality. It's looks like rational on the left, but the right side is not 0, so I have to move them around. I have to move this guy to one side. I want to make one side to the other side to be 0, and I have to simplify that to make it looks like this. Looks like a rational function, right? Or right now it's a rational inequality, and then I find the x value. I call this a boundary point to make both the numerator and denominator to be either to make one of them to be 0. So I found a 2. Then I put this 2 point on the number line. If I put the 2 boundary point, that will break my number line into 3 intervals. And then I pick a test value in each interval. Bring that back to your original inequality to see whether it works. If it does, then I put a check mark. If it's not, I just cross it out. And then that will help you to write your solution, that interval. However, you have to think about whether you're going to use a bracket or you're going to use parentheses. So that takes a little bit of exercise. Okay, so that's this section we learned the inequalities.